All right, page 117. You did numbers 37 to 42, the teal, and 43 to 51, the odd. This was just all review for you. Number 37, you were adding complex numbers. What did you get when you added them, Michael?
9 plus 5i.
9 positive 5i is correct. Number 38, we were subtracting or adding the inverse. Genesis?
11 plus 1i.
What did you have, Maddie?
11 plus 11i.
Did you have 11 plus 11i by any chance? You just didn't see the other one? Yeah, 11 positive 11. I was like, I don't see any way she got the 1. I bet she just didn't read it correctly. 11 positive 11i is correct. Back to Genesis for redemption. Number 40, when we foiled those complex numbers, what did you get?
33 minus 81i.
Now let's take a look at this one real quick here. We had a, let's see, 11 negative 5i times 2 negative 6i. What'd you get when you multiplied your first?
20.
Your outer?
Negative 66.
Your inner?
Negative 10i.
And your last?
Positive 39.
All right, so the negative 66i, negative 10i should have combined to give you
Positive, negative 76.
there we go. And then the I squared becomes,
Negative 30.
well, negative 1, which makes this whole thing negative 30. So when I combine the 22 with the negative 30,
Negative 28.
class, negative 8, right? Just 22, positive 22, negative 30, negative 8. So this should have been our answer there. I'm really puzzled how you got what you got. Did you have these partial products on the way?
I added
Ah.
5 and 6.
Gotcha. Okay, that makes more sense then. And then maybe something else went a little funny there as well. Number 41, what do we have to do in order to divide an imaginary number? Audrey?
Multiply by an I.
Multiply by an I. You can also cancel a 3 out of everything. What do we get for our final answer?
I did it wrong, so I didn't get the right.
Oh. Well, let's do it right. We've got 12 negative 6i all over 3i. And you could cancel the 3 first, or you could multiply the I first. What do you want to do, Audrey?
Multiply by an
All right, so we're going to multiply the I first to get
I. Negative 3.
in the denominator,
And then 12i minus 6i squared.
which becomes,
Positive 6.
there we go. And then we divide everything by negative 3.
4i.
Well,
Negative 4i. 2.
there we go. I'm going to put the negative 2 before the negative 4i. And that's what we should have had for our answer there, number 41. Number 42, we're dividing by a complex number. What am I going to have to do, Abby?
Multiply by the conjugate.
Multiply by the conjugate, which is what?
3 minus 7i.
3 negative 7i. And, of course, that times top and bottom. In the denominator, the whole point of multiplying the conjugate class is to artificially make a sum and difference, which gives us a difference of squares, right? It's to make it so in the bottom, all I have to do, Abby, is
Square the first, square the last, square the last.
there we go, and you got what?
9 minus 49i squared, which turns into a positive 40.
Which turns into a
58.
58. And then in the numerator, we're going to have to FOIL here. Let's go to Brandon. What do we get?
6 positive I, negative 35i squared, which turns into a positive 35. And then I combine this 35 and 6 to get 41 multiplied.
All over 58. And there's our answer. Or 41 58ths plus 1 58i. Anyone go 5 for 5 on these complex numbers? All right, several of you. Anyone go 4 out of 5? Just missed one. Questions on any of these? Abby's looking really hard at this problem.
I see it. I got 29 plus I, so I subtracted the 6. Somehow, for some reason.
Okay. Makes sense what you should have did?
Yes. Yes.
Okay. All right. With confidence like that, how can we fail? All right. Number 43. What is that thing, Michael?
Let me find 43. It is
means an extremes problem.
Yeah, it's a proportion.
Yeah.
And it's all proportions. We know the product means equals the product of extremes, so we just
Multiply both sides by the means. And, yeah, multiply.
what do we call it, class? Cross multiply, right? And when we cross multiply, the means are really easy to multiply.
Yeah, you get 60.
60. The extremes are a pain unless you have a calculator, which we do.
490x.
And to get the x by itself.
Divide by 490.
And we can reduce that really easily.
Yeah, I just took out the zeros.
And there's our answer, 6/49. How many had that answer for number 43? Number 45, Genesis. I really don't want to multiply this the way it is written. Thoughts on that second denominator, or the second consequent, if we're going to use our proportion terminology. Yeah, let's factor that into
plus 3, r minus 2, 5.
And yes, that would give you the negative 2r in the middle. And then notice, class, remember I said if you've got common factors, right, similar factors in numerator denominator, you can cancel them. That's called reducing. No problem there. If you have them in the denominators, you can cancel them because they already wouldn't be able to equal 0 anyway. You're not losing an answer. It's only in the numerator you can't cancel matches in a proportion problem. Well, they are in the denominator, so Genesis, let's go ahead and cancel the r minus 5. Now here, of course, we're left with an r plus 3. What are we left with right here?
1.
Well, I was asking her, but yes, a 1. So now we're ready to cross multiply. Let's start with the extremes here. Is equal to 3r, and then maybe pull a double switch here. Let's pull the 3r over to get, and send the 21 over as a negative 21, and then when we divide away the 4, that's just what it is. Slide the negative out front, but negative 21 fourths. The only thing r couldn't be, originally a 5, we took care of that. That would have been another answer we'd have gotten had we not canceled. You would have had r equals 5 and then had to say, well, no, it can't be. R cannot be negative 3, but obviously that's not a negative 3. So there's our only answer. How many got negative 21 fourths? Anyone also get 5 and forget to say it couldn't equal 5? Questions on that? How many saw the canceling? How many just went ahead and distributed the 7, distributed the 3r, worked with the quadratic, and allowed the 2 answers to come up? All right, that's not a problem. Questions? All right, number 47. On this one, it's not a proportion. We can't just cross multiply. We've got to try to get rid of the fractions here by multiplying class. Multiplying what? Everything. There we go, by the LCD. What is the LCD in number 47, though, Brandon?
W times W minus 2 times W minus 3.
Yeah, W negative 2, W negative 3. And so when we multiply everything by W negative 2, W negative 3, obviously here the W negative 2's are going to cancel, but I'm still going to have the W and the W negative 3. Here the W negative 3 is going to cancel, but we're still going to have, Maddie, the W negative 2, and then here the W is going to cancel, but we're still going to have, Audrey, the... Well, again, instead of looking at this as a 2 and a W and a W negative 3, look at it as a 2W, which gets distributed to W negative 3, Genesis, to get... Then here, look at this as a negative 1W, which gets distributed to the W negative 2, Michael.
W squared negative W squared plus the 2W.
Good. All equal to, and then here the 1 gets distributed, which who cares about that? I'm really just going to FOIL here, Abby, to get?
W squared minus 5W plus 6.
How many got to this point? Check your work. You had that when you cleared the fractions. Questions? All right, at this point we can combine some like terms. The 2W squared, negative W squared class.
W squared.
And the negative 6W positive 2W. All equal to W squared, negative 5W positive 6. Thoughts now, Brandon?
Move over. Or you can cancel the W squared.
Let's cancel the W squares.
And then move the negative 5
To get
W equals 6.
Oh, and we're done. W couldn't be 2. W couldn't be 3. W couldn't be 0. It's not any of those. It's 6. And we have that. Questions on number 47. Been a little while since we worked one of those. Number 49, a radical equation. And 2 key steps to solving a radical equation. Class? Let's try that in unison and get Michael in there as well. What are my 2 key steps, class?
Isolate the radicals, square both sides.
Yeah, radical's already isolated. We just square both sides to get what, Maddie? And then all we have to do is add the 4 to get W is equal to 148. How many out of 148? 4. Number 49. Number 51, we have 2 radicals. Oh, what a shame. And if there's 2 radicals, normally, class, we would isolate the biggest. But, I mean, they're the same. So, what would Audrey pick?
I'm the x minus 1 over.
All right. And so that'll give me the square root of x positive 3 equals 3 minus the square root of x negative 1. Now we've isolated a radical. It's tied for biggest. So now Genesis, we square both sides. The left-hand side is easy because you're squaring a square root. The radicand, yeah, x plus 3. On the other side, it's a full binomial we're squaring. So 3 steps. There we go. And so when we square the first, when we square the last, yeah, the radicand, x minus 1, and we always get what sign when we square, class? Positive. Then we've got to multiply and double. Well, remember, double means times 2. So 3 times 1, 3 doubled, it would be 6. Get careful, not square, but double is 6. Times the square root, careful, of x minus 1. Of course, what sign will we keep right here? A negative there. How many got to that point? Or maybe you had the x negative 1 here and the x positive 3 in both spots. Okay? Either way would be correct. Ooh, questions. All right. At this point, let's kind of clean it up just a little bit. Yes, questions?
I think it's an x minus.
Yes.
It's an x minus?
Yes.
Oh, let's try that. Yeah, that would have really made a problem for us when we tried to solve that. Thank you. All right, how many had that? Oh, okay, all right. So some of you raised your hand earlier. You're like, I know what you meant. Yeah, thank you, Audrey, for not letting us get to the end of it and wonder, why is my answer so different? All right, so now what do we need to do to kind of clean this thing up? Now that Audrey helped clean one thing up, Maddie. Let's cancel the x's. And also, we get, so we're kind of recap where we're at. Negative 3 is equal to 8. Negative 6 times the square root of x negative 1. Continue. Okay, so that's going to give us a negative 11, and you're dividing away the negative 6 to get the radical isolated. But of course, negative divided by negative positive. So this is really 11/6. And now that this radical is isolated, class, I will square both sides. And yeah, I get x minus 1 is equal, class, to 121/36. But I'm not done. I still have to go ahead and add the 1. But I would think it would be easier to add the 1 if we wrote it with a common denominator, 36/36. So really, I get x is equal to 157/36. But anytime there's multiple radicals, class, there's a chance that your root is extraneous. So here we go. Calculator's ready. 157/36 minus 3. What is that?
25, 23 over 26. What's the next number?
It's what?
The next number.
It shouldn't have been negative, though. 157/36 minus 3. What did you subtract?
I don't know.
What is it?
4 and then 13 over 36.
49 over 36.
What's the next number?
Okay, let's try this again. Okay, we're going to do this. We're going to do 157 fraction 36 minus 3 equals 1 and 13/36. Got it? How many got 1 and 13/36 or 49/36 when you subtracted the 3? All right,
Yes.
all right. Now, take the square root of that on the calculator. 7/6. Or 1 and 1/6. Okay? Plus, all right, go back to the 157/36 minus 1. What is that?
13/36.
Okay, take the square root of that.
1.83 repeating.
Make it a fraction. Do you know how to do that on that calculator? If you get a weird decimal, let me show the camera. I'm going to steal his calculator. So at the very bottom of the screen, or bottom is the little backward arrow, but right above it is an F to D with arrows going back and forth. That's you go back and forth between fraction and decimal. So if you got 1.83 repeating, second function, and then that F to D will make it 1 and 5/6. By the way, if you wanted an improper fraction, your fraction button, A and B over C, above it is D over C, which is improper. Second function, D over C, would give you the improper fraction, 11/6. Which may or may not be easier, I don't know. I'm looking at 7/6 plus 11/6, and I'm getting 18/6, which is 3, and it checks. Or you can just gamble that it's right, and if you're wrong, you take the couple points off for not putting no solution. But that's if you're running out of time on a quiz or test. But it does check. How many got 157/36? Or whatever weird mixed number that would be. I hate mixed numbers.
437/36.
What she said. All right, questions. All right. Let's go to page 133 now. And yesterday we began looking at equations that are in quadratic form. They're not really quadratic. Quadratic, remember, if I'll bring the camera back over here, a quadratic equation has squared first gone. But quadratic form would be twice something, that same something that was doubled and then gone. For instance, if this is a 1, double would be a 2. If it's a 2, double would be a 4. If it's a 3, double would be a 6, and so forth, right? Equations in quadratic form. And I said that if an equation is in quadratic form, then we can still set it equal to 0 and factor. And that's what we were practicing with in the homework last night. Page 133, unit numbers 1 through 6, the teal problems, which is basically everything but 5. And let's see how we did there. Number 1, we had an a to the 4th, negative 3a squared, positive 2, all equal to 0. Again, normally we would set it equal to 0. They already did that for us. In fact, they did that on every problem on the page. I'm not sure if they're trying to help us or they're trying to insult us. I'm not sure which. But hey, if an insult helps you out, don't complain. So, speaking of insults, Michael, what will we do here?
Let me see what I did. You gotta factor it.
Okay?
And you get a squared, negative, 2 and 1.
And the outer inner checks, we always want to check that. Then we're going to take each factor class and set each one equal to 0. And so we get two little mini equations.
A squared equals 2, a squared equals 1.
And both of them are incomplete quadratics. We've already got the a squared isolated, so we just take the
Square root.
of both sides. And what answers do we get for a?
A squared equals positive negative, or a equals positive negative square root of 2, positive negative 1.
4 real answers. 2 of them are rational, 2 are irrational, but all 4 are real answers. And we knew we would get 4 answers because the leading power was a 4. How many got those 4 answers? Well, number 1. Number 2, very similar problem. Genesis, we've got a c to the 4th, positive 7, c squared, positive 12 is equal to 0. What do we do?
C squared plus 3c. C squared plus 4c.
Did you say plus 3c? Right? Well, keep in mind, the c to the 4th, that's the c squared, c squared, right? Positive sign tells me both signs positive. All I'm splitting is a 12, right? There's nothing else with the 12, so it's just 3 and 4. The outer inner is where you're going to get the c squared from here, right? That's a 4c squared, 3c squared. So don't focus so much on this as just splitting the 12 and then go from there. Does that make sense? All right, so from here, ignoring the c that we had previously, we should set each factor equal to 0. This one's already written that way. And so that's going to give me two little equations. There we go, and then of course we will. That's a lot of square roots of negatives, class. Anytime you have a square root of a negative, we should Pull out your eye, right? It's imaginary. Square roots of negatives is imaginary. Pull out your eye. So what do we get for our answers here, Genesis?
C equals I times square root, and C equals I times square root of 4.
Of course, we know the square root of 4 is. So we could just say,
2.
there we go, but minus a couple points, class. Positive, negative. Because this is only 2 imaginary answers. I should have a total of 4 answers. They just happen to all be imaginary. Most of the problems we did yesterday, we had a couple real, a couple imaginary. Here we have all 4 real. Here we have all 4 imaginary. But we still have 4 answers. How many of those 4 answers on number 2? Well, let's go to number 3, and we got an r to the 6th, negative 8r cubed, positive 15 equals 0, Maddie. Good, r cubed negative 5, r cubed negative 3. Then turn those into 2 little equations. There we go. And then, when we get to that point, we have to do what? And that gives us what? I'm sorry? Positive, negative, class?
No.
Not on cube roots, remember. You say, well, how many answers do I have, class? 2. Remember, I told you yesterday, that's all you're going to be able to get here is the 2 of them. The other 4 will be complex. Again, showing those factors she had while I was drinking water because I felt that was more important, apparently. And there we go. How many have those answers for number 3? All right, number 4. What did you end up with for your answers on 4, Audrey?
N equals 2 and N equals the cube root of 9.
Yeah, 2 and the cube root of 9 are our answers. Cube root of 8 becomes 2. Cube root of 9 just stays cube root of 9. And again, no positive negatives, no anything weird like that. How many have both answers on 4? Does anyone need to see number 4 worked out? All right, how about number 6? What were your answers there, Brandon?
Y equals 1 and 3.
Good. We have a y equals cube root of 27, y equals cube root of 1, but those cube roots are 1 and 3 respectively. And there's your answers there. Questions on those? How many got both of those, 1 and 3? Questions. All right, I want you to do this very quick. Make your seats. X to the 4th, positive 20 is equal to, where'd it go? It ran away. Negative 12, x squared. Add your seats. That's true when y'all are in here. They're not usually in there. It's usually pre-cal that I'm down here and there's kids next door, so. Fond memories when you were 3.
Yeah.
You're like, was I like that? Probably. All right, Abigail, walk us through while others are still finishing it up.
First with the 12, negative 12x over x positive. So x to the 4th plus 12x squared plus 20 equals 0. Then you can factor into x squared plus 2 and x squared plus 10. Then set both equals 0. And x squared equals negative 2 and negative 10. Then you take the square root of everything to get x equals positive negative I times the square root of 2 and positive negative I times the square root of 10.
And there we go. How many got all 4 imaginary answers here also? Now, the question could be asked, can we use the quadratic formula? Now, this factored easily enough, right? Is there really a need for the formula? Well, probably not. But what if we wanted to? Well, a is still going to be the coefficient of the doubled power x. That's a 1. B is still going to be the coefficient of the x to the lower power, which is a 12. And c is still the constant, which is a 20. But instead of saying that x equals, now it would be x to the n, whatever this middle term power is. So here we'd say that x squared equals, or negative b, plus or minus the square root of b squared, minus 4ac all over 2a. Does that make sense? So we can still even use the quadratic formula, where we could say that negative 12 plus or minus the square root of 144 minus 80 all over 2 is my x squared. And so x squared equals negative 12 plus or minus, let's see, what is 144 minus 80?
64.
Square root of 64?
8.
8 all over 2. Of course, negative 12 plus 8, class. Negative 4 over 2.
Negative 2.
And then negative 12, negative 8
Negative 20.
over 2.
Negative 10.
And those are my x squared values. Then we take the square roots. And that's where we get still the positive negative I squared 2, positive negative I squared of 10. So you can still use the formula if you felt you needed to. It's just you would have, again, if this is 4th squared gone, x squared equals. If it's 6th cubed gone, x cubed equals. You take the cube root of your answers, and so forth. Questions? Let's write this one down, if you would, please. X squared negative 2, quantity squared. Negative 3 times the quantity x squared negative 2. Or excuse me, positive 3. Well, I guess it doesn't really matter. We'll leave it at negative 3. Negative 10 equals 0. I'm flexible. Change it up last minute. Look dangerously. All right. Now here we have a quadratic. We have squared, first, gone, don't we? It's just not an x, it's an x squared negative 2 that's being squared, first, gone. But we can still solve this the same way. I could still backwards FOIL this. How would I split up an x squared negative 2 squared? Anyone?
X squared negative 2. X squared negative 2.
Yeah, x squared negative 2, x squared negative 2. Technically, that entire quantity, right? But that quantity is preceded by what signs right here, class? Positive. So do I really have to write the parentheses? Now they fall off anyway, so I don't really have to group it. But understand, technically it is. My signs? Positive, negative. And how should I split up the 10?
5 and 2.
5 and 2, where I want the 5 to be the negative and the 2 to be the positive. All right, at this point, we can simplify these two binomials. Here, this simplifies down to just x squared. And this simplifies down to
X squared negative 7.
all equal to 0. I'll set both factors equal to 0. Of course, that means that x squared equals 0 and x squared equals 7. And then I take the square roots, and what do I get when I take the square root of 0? Positive, negative? Not really, it's neither positive nor negative. And then here, x is going to equal. Here I end up with 4 roots. 0 and 0, square root of 7 and negative square root of 7. 2 of my roots are coincident. So on the surface it looks like 3. That's because 2 of the roots are the same number. Okay, but yeah, it's kind of a weird thing. Now, this isn't the only way to work it. If you really wanted to, you could square the binomial, class.
X squared negative 4, x squared negative 4, x squared positive 4.
You could distribute the negative 3
Minus 3x squared plus 6.
and have a negative 10 all equal to 0. Then you could combine some like terms
Negative 7x squared.
and
0.
and then you could factor out the common factor
X squared.
times,
X squared minus 7.
oh, that's what we had over there. And then we finish out the same way. So, yeah, a couple ways to work it. Questions on that? Where it's not even just a variable squared first gone, it's a quantity squared first gone. Questions? All right. Another thing I want you to think about for just a minute. We had fractional exponents that we looked at briefly earlier in the year. We had an x to the 1/2 power. Do you remember what the 1/2 power really means?
Square root.
The square root of x. The x to the 1/3 power would be
Cube root.
the cube root of x. So if I had like x to the 1/7 power, class, that would be the 7th root of x. Not 7th power, but 7th root of x, right? So for instance, radical equations, if I had something like, for instance, the square root of x minus, say, 3 times the 4th root of x, say minus 4 equals 0. There's a radical equation, but that thing's going to be a beast. I could actually turn this into a quadratic form equation by using fractional exponents. Do this with me. Let's rewrite the square root of x as x to a power. X to the 1/2. minus 3 times, and let's write this as a fractional exponent, not the fourth root of x, but x to the 1/4. Minus 4 equals 0. And when you realize that we could rewrite these with a common denominator, right? A half and a fourth could both have a denominator of 4. I could write this as x to the 2/4 minus 3x to the 1/4 minus 4 equals 0. Notice I have a 2/4, 1/4 gone. That's in quadratic form. Set it equal to 0 and factor. How do you suppose I would split up an x to the 2/4? X to the 1/4, x to the 1/4. Negative sign tells me positive, negative. The 4 should split up. Let's do a positive 1 and a negative 4, so the outer inner gives me that negative 3. And then set both factors equal to 0. To get x to the 1/4 equals negative 1, and x to the 1/4 equals 4. Let me move this lectern out of the way here. Still following me? Anyone lost? Anyone need me to kind of run through what we did again? Any recap needed? All right. Now, if this said x squared, I'd take the square root of both sides, right? But it says x to the 1/4. So how would I take care of that 1/4 power? What's the opposite of the 1/4 power? 4th. So I'm going to raise to the 4th power on both sides. And here, a 1/4 raised to the 4th cancels to just give me x. Here, same thing, just gives me x. What is negative 1 to the 4th power? Or negative 1 times negative 1 times negative 1 times negative 1? Positive 1. What is 4 times 4 times 4 times 4?
256.
256. We had memorized that rational root. Remember the fourth root of 256, 4. By the way, on your calculator, quick refresher, if I could steal Genesis calculator here. If you're wanting to raise a number to the power, you could say, for instance, 4 to the 4th power, 4, and then the y to the x button, and then hit 4. That tells me I'm going to raise it to a power. It's the 4th power. When you equals, it'll give you the 256. I believe Maddie and Michael, you have a little caret on your calculator, a little finding it. You got, okay, there's the x to the, and there's there, so you do 4, and that would give you the opportunity to do an exponent of 4. You found yours? All right, everyone else good to go on their calculator? All right, because we'll come across some of those things. But here's the deal. These are technically radicals, aren't they? I happened to write them with fractional exponents, but fractional exponents are radicals, which means it's a radical equation, which means I could have extraneous roots, which means I have to check. So let's go back to the original here. What's the square root of 1? 1. What's the fourth root of 1? 1 times negative 3. True or false?
False.
Ooh, okay. Extraneous. Let's try the 256. What's the square root of 256? 16. We memorized this one a while ago. What's the fourth root of 256?
4.
We memorized that as well. Times negative 3.
Yes.
That one checks out. There's my answer. Let's do a few more of these with the rational exponents and make sure we're good to go on these. Again, all kinds of different equations. You can get them into the quadratic form. We can work with them. Write this down if you would, please. X to the 2/3 minus 5x to the 1/3 plus 6 equals 0. Instead of writing cube roots, we have fractional exponents. 2/3, 1/3, no thirds. It's quadratic form, so class, that means we can factor. Already said equal to 0 for us, of course. So x to the 2/3. How should I split that up, Maddie? Positive sign tells me. And the 6. Check your outer inner. Yes. All right, and so we're going to set two equations here. We're going to set the x to the 1/3 negative 2 equal to 0, x to the 1/3 negative 3 equal to 0 to get two little mini equations now, Audrey.
X to the 1/3 equals 2 and x to the 1/3 equals 3.
How do I get just plain old x, class? Cube it all, right? Cube everything. Because when you cube a 1/3 power, it cancels to give you just x to the first. So here x, class, is going to equal 8. Here x is going to equal,
27.
but these are radicals. Gotta check your radical equations. By the way, you could even, you know, I've got a calculator. What am I doing stealing Genesis calculator? I've got a calculator. It's tucked away in that drawer, I never pulled it out. All right, so if I wanted to check, I could even do fractional exponents on the calculator. So 8 to the, which Maddie, you found your button, you know yours. For you guys, it's y to the x, 2 fraction 3. That's 8 to the 2/3 equals. And what is 8 to the 2/3 power, class? 4. Of course, we know 1/3 power is just a cube root, right? So 8 to the 1/3 is the cube root of 8, or 2 times negative 5. Negative 10 plus 6 equals 0? Yeah. 27. 27 to the y to the x 2/3 equals 9. And then, of course, the cube root of 27 is just 3 times negative 5 plus 6 equals 0. Oh, so this time they both check. That was nice. Questions on this one? Don't you feel like you're starting to get the hang of this? By the way, the other way, if you didn't want to use a calculator, because you're, just a snob, you're like, I don't need a calculator, I'll leave it in the desk drawer. 8 to the 2/3 is the cube root of 8, then square it. Cube root of 8 is 2, squared is 4. Cube root of 27 is 3, squared is 9. So you can do it that way as well. You don't have to pull a calculator out, but it can handle the fractional exponents just fine. Write this one down if you would. A, positive a to the 2/3, negative 2a to the 1/3 equals 0. Now here, what is the exponent of my first a? It's a 1. But I could rewrite a 1 as a fraction of anything over itself. In this case, instead of writing a to the first, let's write it as a to the 3/3. And do you see we've got a descending cube squared? Wait a second, is that in quadratic form?
No.
But there's a common factor. How many a's are in every term? At least a third of an a. Here I've got 3/3, here 2/3, here 1/3, but there's at least 1/3 of an a in every term. So we can pull out a third of an a as our common factor, a to the 1/3. If I pull a to the 1/3 out of a to the 3/3 class, I get a to the 2/3. Pull a to the 1/3 out of a to the 2/3, I get a to the 1/3. And when I take the a to the 1/3 out of the negative 2, a to the 1/3, I just get questions. Anyone lost? I don't want to lose anybody. We all following? All right. Now then, 2/3, 1/3 gone. This is quadratic. It was quadratic now that I got the common factor out. So keep the common factor, don't lose the common factor, or we can backwards FOIL. How do I split up an a to the 2/3? Genesis? I'm sorry?
1/3.
A to the 1/3 and
1/3.
a to the 1/3. Negative sign tells me
They're gonna be
difference, so positive, negative, and then how do I split up the 2? 1 and 2, check the outer, inner. Yeah, I got a negative 2, positive 1 is negative 1, so we'll switch and make the 2 the positive, make the 1 a negative. Now it checks, and now I've got 3 factors. Each needs to be set equal to 0. So a to the 1/3 equals 0. Here, class, a to the 1/3 is going to equal 1. Here, a to the 1/3 is going to equal negative 2. And what am I going to have to do to every single one of these values? Cube them all. So, I get a equals what 3 possible answers? 0, 1, and negative 8. But we better check. 0 to any power, class, is 0. So 0 plus 0 minus 2 times 0 equals 0?
Yeah.
That was easy. Donut. Enjoy, Michael. It's not filled. All right. All right, then try the 1. Well, 1 to any power or root is still 1. So 1 plus 1 minus 2 times 1 equals 0?
Yes.
Yeah, 1 plus 1 minus 2 is 0. So the 1 checks. Now for the 8. Obviously, this is just a whole power, right? This is just the first power. So negative 8 to the first is still negative 8. What is the cube root of negative 8? Square that negative 2. Positive 4. And then cube root of negative 8 times negative 2, positive 4 equals 0. All 3 answers checked. No extraneous roots. Questions on that one? How about this one? Write this one down. X to the 1/3 minus 3x to the 1/6 equals negative 2. Well, first of all, 1/3 could be thought of, Brandon, as 2/6. So I've got 2/6, 1/6, and then let's bring over the gone equals 0, right? 2/6, 1/6, gone equals 0. So far, so good? And then we what you call factor, right? And when we factor, what do we get at?
X to 1/6 and x to 1/6. Negative, negative. 2 and 1.
All right, and then we're going to set each of these equal to 0 to get 2 little equations. X to the 1/6 is equal to both
2 and 1.
2 and 1. But what am I going to have to do to get the x by itself, Michael?
6th power.
Everything to the 6th power. Well, of course, that cancels the 6 with the 1/6 to just get x. 2 to the 6th class,
64.
64. And a 1 to the 6th.
1.
Let's check. What is the cube root of 1? What's the 6th root of 1? Times negative 3? Equals negative 2? All right. Now for the annoying one. Well, not really. What's the cube root of 64? Uh-oh. 4. We memorized this one. All right. What is the 6th root of 64?
2.
2 times negative 3 equals negative 2?
Yes.
Hey, this one check. It's just the first problem had the extraneous root in it, but always check as it could. Right? I think we got time for one more. Let's do just one more problem here. Are we feeling like we're getting the hang of it now? Maybe initially our thought was, what is going on? But do you feel like you're starting to see the pattern? It's really the same thing we've been doing the last couple of days. It's just fractional exponents. Another weird way to approach radical equations. Questions? All right, let's do one more. Write this down. If you would, m to the 4/3 minus 3m to the 2/3 equals 4. M to the 4/3 minus 3m to the 2/3 is equal to 4. What do you suppose we should do first here, Genesis? Good. Set it equal to 0. Bring that 4 over as a negative 4. Then what do you suppose we should do, Audrey? How?
M to the 2/3, 1 to the 2/3, plus and minus 1 and 4.
All equal to 0. Of course, set them each equal to 0 to get what two little equations? Brandon?
M to the 2/3 equals negative 1, and m to the 2/3 equals positive 1.
Now, question. I just want a plain old m, right? If I had a 1/3, I multiply by 3. Bam, it's a 1. If I had a 1/6, multiply by 6. Or raised to the 6th power, right? So the 6, when I multiply the exponents cancel, I've just got a plain old x. What power would I have to raise this to make that become a 1?
3/2.
The 3/2 power, the reciprocal power. Does that make sense? So now the 3's cancel, the 2's cancel. As you multiply the exponents, because you're raising a power to a power, you just get m. But what you do to one side, so I'm also going to have to raise the other side of the 3/2 power. Now be careful here. Your calculator can't do this, because your calculator can't do imaginary numbers. And that's what we're going to get here. Remember, a half power is the square root. What is the square root of -1? I. Cubed becomes negative I. Or, if you'd rather, you could do it the other way. You could say, let's cube the -1, and then take the square root of -1. I. Though technically, positive negative I, right? Just technically here, if you take the square root of -1, okay, so let me show this again. -1 to the 3/2 means the square root of -1 cubed, or it means -1 cubed and take the square root. Does that make sense? This is square root, that's cube. So you take the square root, then cube, or you cube, then square root, either way, right? So if we square root positive negative I, and then we cube it. If we cube it, that's -1, which then we take the square root, that's a positive negative I. So here if you cube a positive I, class, that's I cubed, which is negative I. If you cube a negative I, it gives you negative I cubed, which is negative I, which is positive I. Either way we get positive negative I. I lose somebody here, I feel like. It's like a second hour, what are we doing? Questions. Too early. Let's go over here. What do we have to do to get the m by itself? Well, raised to the reciprocal power. 3/2 power, so when you multiply the exponents, they cancel. Thank goodness this isn't a negative. All right. We can either cube it first or we can take the square root first. Which one do we want to do? Square root first. What are the square roots of 4? Positive -2. And then let's cube them. If we decided to cube it first, we would have gotten 64, and then we would have taken the square root to get positive -8. 4 answers, 2 of them are imaginary, 2 of them are real. Let's check the real answers first. Let's try an 8. What's the cube root of 8? Cube root of 8? 2 to the 4th. Cube root of 8 squared times -3 minus 4 equals 0. Yeah. Let's try -8. Cube root of -8, -2 to the 4th. Still 16. Cube root of -8 squared, still 4 times -3 minus 4 equals 0, of course. So both of those check. Now the i's. Well, see, I to the 4th, 1. Cube that, or cube root of that, excuse me, 1. I squared -1, cube root of -1 times -3, positive 3 minus 4 equals 0. Now for the negative I. Gotta love this. Last day before Thanksgiving break. What are we doing? All right, you're making you really thankful for Thanksgiving break, right? Yes. Making you thankful for the bell that's about to ring. All right, negative I to the 4th power is still going to be positive 1. Because negative to even power is positive. I to the 4th is 1. So still positive 1. Cube root of positive 1 is still 1. Same thing here. When you square it, negative squared becomes positive. I squared is just -1. Cube root of -1 times -3 is still positive 3 minus 4 is 0. All 4 answers check. 2 imaginary and 2 real. Questions on this? The best news you've heard all day. I'm not going to give you any homework over this tonight. We will pick this up after Thanksgiving break. We'll let you have 10 full days off to let your brains recover from the trauma to which I have just subjected them. I'm not sure if you feel smarter or dumber now. How many feel like, hey, I feel smarter because I understood that and that was weird. Anyone like, I'm totally lost. So I thought I was smart, now I feel stupid. All right, you're not stupid. That's just weird. Imaginary is just weird. Everything was going great until the eyes came out, right?
Yeah.
Yeah, same with sports on a sports team. Everything's great until I starts coming out. And it's, oh, cry. Anyway, have a great day.